Here we are with a young physicist, Kaye Morgan, and she's going to tell us all about new way of seeing with X-rays.
Okay, so X-rays are really just another kind of light. It's just they have a lot shorter wavelength than visible light. So we can actually use visible light as an analogy to describe the type of imaging I do. So with conventional X-ray imaging, you're usually looking at what's effectively a shadow. So we can illustrate here if we've got a mug. This is our X-ray detector here, and if we shine a light, a phone, you can see there's a shadow there. And so the mug is kind of like the bones in an X-ray image. They absorb the light or the X-rays, and so you get this shadow image and you can see what's going on. The problem is when you try to look at something like soft tissue, the X-rays, most of them just go through, they get absorbed about the same amount, so you can't really see something like the lungs in an X-ray image normally. So what we actually do is we do phase contrast X-ray imaging. So instead of just looking at how the X-rays decrease in intensity, we also look at how the phase changes. So if we have, for example, a glass, the light through there, most of the light's going through it, just like with a normal X-ray, you get most of the light goes through the tissue. But you can see we get some patterns that are due to the different, the refractive index of that particular material. So what we do is we do the same kind of thing as that with X-rays, do some maths on the image, and we can actually reconstruct things like the lungs or the airways and use that to help medical researchers see new treatments in action. So we actually use the synchrotron just across the road from Monash for this imaging because it creates really, really bright X-ray light. And so we can choose a certain wavelength of light, and we also get really coherent light, and we can take high-speed movies with a field of view of only 1 millimetre. So the whole field of view that we're looking at just is a millimetre on the surface of the airway, and see the effect of treatments on that surface in real time.
So what kind of treatments is this good for?
So we're working at the moment with a team from the Women's and Children's Hospital in Adelaide, and they have a new treatment for cystic fibrosis. And so they should be able to see a change in the amount of liquid that's on the airway surface in response to their treatment. And so we're looking at how big that change is and how long it lasts as well.
That's great. Thank you.
No worries.